All right, example 2 from today. We're going to have an automobile chase. Have 2 cars. We went with James Bond on the first one. And that speed was 40 meters per second. Let's call that one car B. Okay, and the acceleration here is 0. Initial velocity is 40. Okay, then it's being chased by Spectre. Spectre always have those kind of goofy looking cars. Call that car A. Here the acceleration is 5 and the velocity initial is 20. So we start out slower, but of course we're going to speed up. Now the other thing is we'll make this a little trickier, and that we'll say there's 200 meters in between them. So we'll start the clock at the same time, but the solution to this problem is going to come with a deficit in position. So we start with a different position. They're not side by side. So we need functions, and we want the 3 questions to be this. We want first question to be how long to catch. So A catches B. Second question is going to be what's the velocity of B final. And third question is going to be what is the velocity of A final? How far does B travel in that time? Okay, first functions. So for car A, we're uniform accelerated motion. We're looking at position as a function of time, because at some point they're going to catch up. Okay, so for A, our function might be delta x is vi xt. Now let's call it A, I suppose. Delta x of A, vi t, plus 1/2 A times t squared. So we have a function because this is going to be 20 times t plus 1/2 of 5, 2.5 t squared. Now the decision we have to make is the delta x. Remember, that's going to be a difference in positions. X final of A minus x initial of A. I'm going to say that car B starts at position 0 meters. Therefore, car A is 200 meters behind car B. So that means my x final minus a negative 200 meter is going to be equal to 20t plus 2.5 t squared. So I can get an x final of A being 20t plus 2.5 t squared. This will be a plus, now it's a minus coming on the other side, minus 200 meter. Okay, now I can have a function for car B. B does not have any acceleration. I'll write the equation now. Delta xb, vi b t plus 1/2 acceleration A of b t squared. That term is 0. We're not accelerating. Again, delta xb, that's x final of b minus x initial of b, is equal to 40 meters per second times t. Okay, and remember, since I called b's initial position 0, that makes this 0. So my x final of b is going to be equal to 40 times t. Time is the same for both. We start the watch when they're 200 meters apart, and then car A starts to accelerate. Well, we also know that the final position of A and the final position of B are going to be the same. So we can equate them, 40t being equal to 20t plus 2.5 t squared minus 200. It's our quadratic again. So then 0 is going to be equal to 2.5t squared, bring the 40 over as negative, minus 20t minus 200 is equal to then 0. You solve it as a, well, don't forget the negative here, b, don't forget the negative, c. So we solve this equation for time with the quadratic, and we get something like 13.8 seconds. Okay, so we answered part A. This is 13.8. Velocity of A final, so that's the bad guys are going to try to catch up to 007 here. I'm going to erase this. We're accelerated motion. That means the equations of constant motion will function. So the final velocity of A is equal to the initial velocity of A plus the acceleration of A times t. Initial velocity of A was 20. Acceleration is 5. And the time was 13.8 seconds. So if we did a little quick computation there, that turns out to be 89 meters per second. So we're cooking pretty well there. Must have a jet propulsion or something. So that's part B, 89. Okay, for part C, how far does B travel? We can use this function. The final position of B is equal to 40 meters per second times the time, 13.8 seconds. Multiplying those two together, you should come up with something like 552 meters. Well, how do you know you're right? Sounds reasonable. Well, you guessed it. You can plug back into this equation, right? For A, recognizing it's 200 meters behind, we can still find x final based on the zero position for B. So, x final, remember this was minus a minus 200 plus 200, is 20t plus 2.5t squared. So x final of this is A is going to be equal to 20 times 13.8 plus 2.5, 13.8 squared, minus 200 meters. So plugging that in, .1, which is the same as we have for the position of B. Okay? Remember, accelerated motion can come in many forms. We can look at this problem many different ways. What if we turned it vertically? I wonder. There is a practice problem like that on the review. Maybe you want to have a look at that.